In this tutorial, we're going to generate a standard curve, and we're going to use that curve to calculate the concentration of an unknown solution. So the first thing we're going to do is in Excel or any other spreadsheet program, we're going to put the data in for the spectral readings that we obtain. In this case, it's for cobalt chloride. And we started with a known concentration of cobalt chloride, and we made a series of dilutions so that we ended up with, for example, 50 millimolar, 300, and up to 500 millimolar cobalt chloride. And then we read the absorbance of each of these solutions at 500 nanometers. For example, the 50 millimolar solution gives us a reading of 0.05, and the 300 millimolar solution gives us a reading of 0.46. The next thing we're going to do in Excel is select these two columns, and we're going to go to the graph function to generate our graph. In this case, we're going to use a smooth marked scatter, which is highlighted here, and when we release that, we'll see our graph pop up. So this is the graph of the data. It's not perfectly linear, but in Excel and in most spreadsheet programs, you'll be able to use linear regression to make this look like a perfectly straight line. And before I do anything else, I'm going to add labels to the X and Y axis. And again, as we did before in the other tutorial, we're going to go up to the function axis titles, shown here. And I want to remind you that to see these options, at least in Excel, you actually have to have selected your graph before these options will be available. The first axis title I'm going to do is the horizontal. Remember, when you're in axis titles, you can select either the horizontal or the vertical. And we'll show on the next slide that we end up adding the label cobalt chloride concentration, millimolar, because that's what's on our horizontal axis. And then we can do the same with the vertical axis, and we label that absorbance units. I also have the option of relabeling the title, so I gave it something that's a little bit more informative instead of absorbance 500, which is what I had on my original graph. I added absorbance of cobalt chloride at 500 nanometers. It's a little bit more informative. Well, now we want to get a straight line from this. So what we're going to do is we're going to select that line, put your cursor on that line, and you'll get some options to manipulate the line. Now I'm showing you the menu that you get in Excel after selecting your line, and what I'm going to focus on now is this category over here called Trendline. And notice I've already selected it, and it says add a trend line to the chart. And when you select that, what you get is the option of adding a regression type, and in this case we're selecting the linear regression. And I'm going to hit OK, and I'm going to see that I now add a linear regression to my graph. And it's added a new legend, and it's added this black line, which is the linear regression of the data. Next, we're going to use another feature of Excel that allows us to determine the formula for that line. So in this case, we're going to click on that black line, which is our linear regression, and we'll get some options in Excel back at the same category we were at below previously, and we're going to this time click Trendline Options. And when we get that, we will see that there are a couple of features. You can change features of the line, etc. You can change the type of trend line that you wanted, but we were on a linear one. And this time what we want to do is we're going to look down here at display equation on chart. And then we're going to hit OK. And this is what we get. The only thing that's different now is that we're showing the formula for that line. Now notice that where it crosses the intercept is a very low number. It's almost 0, but we had 0 data, but when we did the linear regression, it turns out that it's actually not quite 0. But this is really the number that we're going to be looking at, and we're going to use this entire formula to determine the concentration of an unknown sample that we looked at. The point of making my standard curve was so that I could use that linear line, that linear regression, to calculate the concentration of any unknown cobalt chloride solution, as long as I can measure the absorption. So here is my unknown cobalt chloride. And again, I don't know the concentration, but when I measured the absorbance, again at 500 nanometers, I find that the absorbance is 0.36. Now I can plug that number into the formula, and here's how I'm going to do that. We remember that we're looking at the x and y axis. Here's the x, and what we're plotting on the x-axis is concentration. That's what we don't know in this case. What we do know is the number 0.36, which is the y value, so we can plug that in right here in place of y. And when we do that, we get the formula shown here. 0.36 is now equal to 0.0014x minus 0.0068. And now we just have to do some very simple math manipulations. First, we're going to get rid of that 0.0068. We can do that by adding 0.0068 to both sides. That eliminates it on one side of the equation, the right-hand side, so that we've now simplified this to 0.0014x is equal to 0.3668. And now we simply divide by 0.0014. Of course, that simplifies this side to just x, and we come up with a number of x is equal to 262. What does that number mean? Well, what 262 means is 262 millimolar, so we're right about here. That's the concentration of my unknown, and remember the absorbance of that was 0.36, and if you go up here, 0.36 is about up here, and if you go straight across and straight down, you could use your graph to estimate this concentration, but using the equation gives us a more precise value.